The derivative of the function at a point. Given a function defined by y is equal to f of x, the derivative of the function at the point x sub 0, y sub 0 is the slope of the line that is tangent to the function at x sub 0, y sub 0. Our notations for the derivative of the function at the point x sub 0, y sub 0, f prime of x sub 0, or sometimes dy over dx, evaluated when x is equal to x sub 0, or sometimes df over dx, evaluated when x is equal to x sub 0. So these three notations for the derivative of your function will give you the slope of the line that is tangent to your function at point A. So how do you find the slope of a line that is tangent to the curve defined by y is equal to f of x? So let's say, for example, we have this function and its graph is given by this curve. The line that is tangent to that curve at that point, okay, so let us say this has coordinates x sub 0, y sub 0, has a slope. But we cannot jump into computing for the slope of the tangent line right away because normally we need 2 points to compute for the slope of a line, change in y over change in x. And what we did last time in our previous videos is to estimate the slope of the tangent line by constructing secant lines. So the secant lines will intersect your curve at 2 points. And one of the point of intersection is going to be fixed. It's going to be that point. And so we can compute for the slope of this secant line. But what we shall do now is we shall produce more secant lines. And our secant lines are going to approach the tangent line. As our secant line approaches the tangent line, it will produce a sequence of points of intersection, but this one is fixed. But this one, as the secant line approaches the tangent line, this point is going to get closer and closer to that fixed point. And then when we get sufficiently close to that point A, what we shall get is a fair estimate of the slope of the tangent line. The derivative of a function at point x sub 0, y sub 0. So the derivative of the function at that point is the slope of the line that is tangent to the curve at x sub 0, y sub 0. Okay? So let's say, for example, this is our tangent line, and that is the point of tangency, and its coordinates is x sub 0, y sub 0. The derivative of that function at x sub 0, y sub 0 is the slope of that tangent line. MTL is equal to change in y over change in x. But we cannot directly compute for change in y over change in x because we don't know other points besides the point of tangency. So what we do is we produce a sequence of secant lines, and those secant lines are going to have a slope. We shall estimate the slope of the tangent line through those sequence of slopes. The slope of our tangent line is going to be approximately equal to delta y sub I over delta x sub I. So for every secant line, we are going to produce a pair of points. This is one of the point, and this one will be the other point. And with those 2 points, we can compute for delta y sub I over delta x sub I. But the true slope of the tangent line, is equal to this. It's equal to the limit of delta y sub I over delta x sub I as delta x sub I approaches 0, if the limit exists. So where did delta x sub I approaches 0 come from? It came from this. So your second line will produce 2 points. Those are the points of intersection. One is a fixed point. So this point is going to have an x and y coordinates. And the x coordinate of that point is going to have a distance from the x coordinate of your fixed point. And that distance is what we call delta x sub I. And as we produce our sequence of second lines, we are producing a sequence of values for the slope of those second lines. And as the other point of intersection gets closer to the fixed point, the x coordinate gets closer to x sub 0, in which case delta x sub I approaches 0. So that is why we have that. The limit of delta y sub I over delta x sub I as delta x sub I approaches 0. So these are the things that we must remember when we are talking about the derivative of the function at point x sub 0, y sub 0. It is the slope of the tangent line to the curve at x sub 0, y sub 0. And you know slopes, okay? You know slopes. Slopes is something that you are comfortable talking about because you heard about slopes as early as grade 7. The slope of the tangent line at the point x sub 0, y sub 0 is the derivative of the function at the point x sub 0, y sub 0. Or another way of saying it is the slope of the tangent line to the curve is the derivative of the function when x is equal to x sub 0. So slope is a measure of rate of change. Okay? So that is what we are measuring here, rate of change. But this is not your ordinary rate of change. Because normally when we are computing for the rate of change, it's delta y over delta x, change in y over change in x, and we need 2 points to do that. It requires you to get the difference between two values of y sub 2 minus y sub 1. And then for delta x, you need two points to produce x sub 2 minus x sub 1. But we don't have that here. We only have 1 point. And so the derivative is not just a measure of the rate of change. It is a measure of the instantaneous rate of change of the function at a point.